Hello everyone, now we are going to solve the questions based on the torque method. Consider the system shown in figure below. The mass M is attached to the load AC. Here in the diagram you can see there is a load AC is given. Okay, this is AC load. At a distance x from the hinge point at B, this is a hinge point. So there is a distance x, there is a mass M is fixed. Okay, here you can see this is the mass M and the value is given, that is 30 kilogram. Two spring of stiffness 3K and K are attached to the load at points A and C respectively. The natural frequency of the angular oscillation of the system about B. In the question it is given that there is an angular oscillation about B. Okay, and the natural frequency is given, that is 20 radians per second. Assume the rod to be rigid and massless and find out the magnitude of x in meter. So this is a simple question. This is not a tough question. Just you have to apply the torque method and you have to write down the equation. So we are considering the angular oscillation of the system. So it would be like that. If I rotate this rod clockwise through an angle theta, it would be theta, and this would be also theta. Okay, both the angle would be same. So now we are going to write down the equations. So we know that this is the angle theta. So I theta double dot will be opposite to that. And if I'm talking about the first spring, this is the first spring. The spring force would be in the directions, and it would be K. If this is completely 6, so 6 theta multiply. We are going to consider torque, so that would be multiplied with 6 because this is the oscillation about point P. Okay, this is about this spring. Okay, now the second spring is of stiffness 3K, so it would be 3K multiply the distance is this is AB, that is 2 meter, 2 theta, because we are considering arc. Okay, this is the arc of spring, that means the displacement of the spring is this, that is nothing but the theta into R is nothing but 2, and the torque we are going to consider, so we have to multiply with 2. Okay, remember that sometimes spring constant are same for both the springs, sometimes it is different. Okay, so be careful about it. Now this is a horizontal system, and we know that in a horizontal system mg torque is not considered. This is very important note, you just have to be write it down. In a horizontal system, in vertical system you can consider, but in horizontal system, mg torque is not considered. Mg torque is not considered. This is only the condition when the system is horizontal. Why it is not considered? Because in the rest condition, mg is balanced by the spring force. That means the initial deflection of the spring. Okay, so there will be spring forces. So mg is balanced by that force, that spring force initially when the springs are in, when the system are in rest condition. But as we rotate with the theta angle, there will be mg torque which is not going to be considered. So here we are going to write down the equations. We all know how to write down. This is I theta double dot, and the second is, this is K 6 square theta plus K 2 to the 4 and 4 3 12. So that is K 12 theta is equal to 0. Now this is 12 and this is 36. So when you add it, you will get 48. So it would be I theta double dot plus 48 K theta is equal to 0. Now this is the equations. Now the simple is the question is Where is he now? Now just have to find out the value of moment of inertia. So I is the moment of inertia. So how can we calculate? This is completely a rod which is massless. Okay, this is the massless rod. So we don't consider the moment of inertia of this rod because this is massless. Okay, only mass is given, that is this. So the moment of inertia would be I would be equal to m l square. That means mx square because in the question it is x square. Okay, so we just have to rearrange these equations so that we compare it with the general equations. Upon I is equal to 0 and this is omega n square. So this is omega n is equal to under root of 48 k upon I. Okay, and the omega n is given, that is 20 radian per second. So when you remove this under root, you will get square on the other side. So it will becomes 20 square is equal to 48. What is the k value? 1. That means 1000 multiply 1000. Unit must be same. And what is I? I is mx square and the value of m is 30 kilogram x square. So when you solve this, you will get the value of x. So it will get, so the x value you will get 2. So this is 2 meter. Okay. So I hope you will understand the solution of this question. Again, I am explaining this question. This is not a complicated one. Generally, I will suggest you to apply the torque method in these type of questions because you just have to write down one equations and you will get the answer with a very short time. So in the question, it is given that there is a mass m which is fixed to a rod AC at a distance x from the hinge point. Okay, and there are two springs. So one is having a stiffness 3k and another is having a stiffness k. Now we have to find out the value of x here, and the natural frequency is given. Natural frequency is given, that is denoted as omega n. Now we know that in a horizontal system, mg torque is not considered because mg is balanced by the initial spring force. So when you write down the equations, that means rotate this load by theta angle, and you will get here inertia torque that will be at theta double dot in opposite direction. So there will be a spring force torque, and this is a spring torque because there are two springs. One is having stiffness K and another is 3K. Sometimes in the question they will give you the same stiffness, and sometimes it will not be same. It is according to the question. So when you write down the equations, you will get these equations. So just rearrange this equation and you will get this equation, and this complete term is nothing but omega square. You know that this term is nothing but the omega n square. Okay. So that means omega becomes under root of 48k upon I. And what is value of I? I is nothing but the mx square because the load is massless. So that's why we cannot consider the moment of inertia of load. Only there is one mass, that is m is equal to 30 kilogram. So we can consider the moment of inertia. You just have to put the value and you will get the final answer. That is x is equal to 2 meter. So I hope you will understand the whole procedure. So